So let me just start. I think, a lot of these discussion on the career and the program will be towards the end. So as people keep coming in, they can hear those components in detail, right? So I will just start with a brief overview of data science. So thank you once again for joining. So I am Professor Soumya Choudhary. I'll just give a brief introduction. I am the person responsible for this PGDM data science program for IFM Business School. I come from industry. I spent around 23 years working for different type of companies and industries. So I spent some time in management consulting, in investment banking, in automotive, and then in IT services, and in very different kind of roles, starting from, of course, management consultant, mergers and acquisitions banker, person who created a supply chain business for an automotive company and ran that business. And then in IT, I used to be part of the large deal team responsible for application development, maintenance, sales. And essentially what it meant was these were large contracts which had different components of application development, maintenance, and even some of the digital areas, right? So I have quite a bit of diverse experience. So I think I can very confidently give you some of the snippets of, which are the companies that probably be the employers of the future and how data science is relevant, right? So I will just move into the main presentation. Okay, so what we will cover is, a primer on data science. Also give you some of the, differences between what is known as machine learning, which is the traditional machine learning, and the deep machine learning, right? Which everyone today thinks it's the hottest sector. So I will try and cover the differences between the two and what that entails in terms of the curriculum and so on. And then moving forward to what is the kind of careers that one can expect in data science based on the experience and exposure one has. And then talk about the specific program, right? So, okay. So if we really look at data science, there is a lot of misconceptions about what the term means, right? So it's basically the study of data. So, okay, data and science, right? So no points for guessing, but I think the critical thing today is that data science is all about, how you can manage data at scale and be able to use the data effectively to be able to throw out, deep insights. So if you really look at how volumes of data have ballooned over the years, you had conventional ERP like SAP Oracle, where you talked about the whole database being in size of terabytes. So a terabyte is 1,000 gigabytes, right? So it's essentially 10 raised to 12 bytes. And then you had, the Office 365 kind of applications, which moved you into petabytes. So that was 10 raised to 15. And then you have all the current web applications and a lot of videos and different kinds of data, which is taking you to exabyte scale, right? So exabytes is 10 raised to 18. And so if you really look at the data that is generated per day, you are basically seeing something like, huge amount of emails, WhatsApp messages, and so on, which are coming up. We all are creating data, and every 2 years, data is doubling. And so if you take all this and you look at 2019, we had 5 zettabytes of data. Zettabyte is 1,000 exabytes, so 10 raised to 21 bytes. And so the whole of 2019 had 5 zettabytes of data created of all kinds. And IDC and Forbes predict that that will go up to 175. So you can really imagine, what is the kind of multiplier you're having there, right? So you have 35 times the data being created in 6 years, which means obviously you're doubling, more than doubling every couple of years. And then what we will find is that we will soon move from exabytes and zettabytes to what is called yottabytes and brontobytes, right? So these are all, I think, general knowledge in case this is of interest. So we all move in logarithmic scales, which is in thousands. So scale of 1,000 times means a log scale of 3. So that's what you're seeing in this graph, that, it's moving from 1 to 3 to 6 when you're moving from terabytes to petabytes to exabytes, right? And that's really where you're seeing this exponential growth in data, and that's why it's becoming so important for someone who's able to analyze data at scale and be that one-man army who is bringing in the ability to analyze data and interpret data and be able to, one, understand the insights from it and also the managerial implications, right? So that is where we are coming to, that data science is not just about technology and IT skills. It's also about, domain and business skills. So someone who combines both these obviously are at an advantage. So I think this is something we know, and maybe I'll just talk about the fact that, really big data we've all understood is managing, data and the exabyte and zettabyte scale. But what is the output of this, the data science as a product? What is the output? The output is, as I mentioned, insights. So you will need a good balance of math and statistical understanding, because what we are trying to do is we are trying to prove a hypothesis, what is called the null hypothesis, disproving, or, if it cannot be disproved, means the null hypothesis is true, based on observations, where you're basically taking a sample and you're trying to compute what is the mean and variance, and then trying to find out whether it lies within confidence intervals and so on. So all the things we have learned in statistics, right? And then, the significance levels, which is the p-value. So ultimately, what you're trying to do is you're trying to get insights through data. And you also need to understand the format of the data, right? So whatever is there in the data sets, you need to really understand, what data is, there with high degree of reliability. What data columns are blank because data is not available there. What are the features or, the main components or independent variables which would determine, a dependent variable, or, the y, which is explained by many x factors, right? So which is the regression as we normally know it as. And then be able to kind of keep understanding from results which are the kind of set of independent variables you need to actually include in your analysis, which gives you deeper insights, and you don't need to kind of really use more than those features or independent variables. So that's where the understanding of the data or deeper insights come into play. And then you have this whole, like I said, domain or industry knowledge, which is important. So the key question is data science new? Is this something which is a new area of knowledge? So what would be your answer to that? If you were to look at data science, and a lot of people talking about it over the last, I would say, decade or maybe last 5 years. So is your understanding, you can just type it in the chat box, do you think it's a new field? So data science essentially, I would say, is something which is, the knowledge is not new, but it is the ability to be able to. Okay, so I think Priyanshu says it's a new field. Okay. Anybody else who believes data science is new? So who invented zero? So zero was invented in India, then went to Persia, Iran, or Mesopotamian civilization, went to Egypt, so on, right? So a lot of mathematical concepts actually originated in India, but I would say a lot of these concepts in mathematics were, of the 1600s, right? A lot of them got refined over a period of time. But the issue where we are, really talking about data science being a new field is actually uh, the same thing about deep machine learning and traditional machine learning, right? Deep machine learning allows us to manipulate, whole, sets of data, which is, running into, um, you know, let's say petabyte or exabyte scale. And what that means is high compute power. So this whole computational and cheap storage, which cloud has commoditized for all of us. Earlier, you had very expensive data centers. Only the largest corporations had access to that kind of compute facility. So the computational power becoming cheap and access to whole host of data, which is not only what resides within the enterprise, but also from, public data sets and external, paid sources where you can enrich the kind of analysis you can do. So that is what is new. And based on that, we have been able to come up with better insights. So when we say it is new, it is actually the fact that because of these two, I would say, additional infrastructure elements, it's now reality, whereas earlier we could never do this. So that's really what is new. Yeah, so I think Arpit says that, correctly, that, yeah, it's only kind of something that we have been able to realize with the kind of elements we have now. So if you really look at the three pillars of data science, one is what we talked about, this whole data collection, storage, and tools, which, on which you can, pull libraries of models and various things. So it's giving you that whole access to a set of resources, like a library, right? I mean, it's a virtual library instead of a physical library. So whatever skill sets are required to pull that kind of knowledge to you is what is defined in technology. Data science itself, the top pillar is around stat models and machine learning algorithms. So this is the knowledge of math and statistics, right? So you have to have a good knowledge, and these are all taught in the course. These are not that, you have to come with that knowledge or have a, past background in statistics and maths. But yes, you must be comfortable with maths. I mean, it's not something that you should be scared about, because I know a lot of people are scared, and so you sort of, really sort of need to be able to embrace the new concepts that are taught and be able to learn it quickly. It's not that, it will take you a lot of time to ingest that. Of course, there has to be effort, and it's, a combination of how quickly you pick up and how much effort you put as homework. But I'm just saying that this is something that is taught, and this is not a prerequisite for this program. And the third pillar is really the business context. This is what comes with years of experience. So if you have had work experience, and I was actually trying to run a poll of how many people are fresh and how many people have industry knowledge. So for instance, people who come from, let's say engineering, or who have worked as interns in some organization would have a good understanding of that particular industry. So that is what I mean by, understanding the business context in that particular industry. So you could have worked in IT, or you could have worked in, any other services industry, or you could have worked in, even a manufacturing setup. So in manufacturing, let's say it was something related to plastic manufacturing. So now you know a lot about plastic manufacturing, how injection molding happens. You may not know exactly how it happens, but you know broadly what is the process steps, what are the things people need to bother about in, plastic injection molding, for instance, what is wastage, what are the determinants of profit, right, for that enterprise. That's what I mean by business context. So with that, you are able to define the problem. So the problem is, what are you trying to optimize? Optimize is that you're trying to, get the best value, right? So you're trying to, let's say, get the highest profit for your company, right? So for that highest profit, what are the components of cost which are the highest percentage of costs, right? So let's say for manufacturing, it will be typically material cost. So then if you have to choose between material cost and manpower cost, and let's say material cost is 50% of sales and manpower cost is 10% of sales, right? In a typical manufacturing setup, that's the kind of numbers. Like I said, I worked in automotive, so I spent a lot of time, trying to do these kind of analysis. So then, what would happen is, if you try and optimize on material cost, you would actually have 5 times the effectiveness of improving profits that you would if you were to try and optimize manpower cost. So where would you spend your time, right? So you would try and optimize costs by optimizing that, and then similarly, admin cost could be 2%. So between manpower and admin cost, you are much better placed by focusing on manpower cost, so and so on and so forth, right? So these are the things where the business context becomes very important. And then you decide, okay, I have to optimize for this. What is the kind of data I need, right? So you'll have to go back, search for the right kind of data to be able to analyze what is going right and what is going wrong, and then leverage some of the models, right? So that is what, in very simple terms, is what data science tries to teach you. So as you see, if you're trying to address these kind of problems for an organization or a company, clearly you're the person who is the most sought after person by let's say a vice president or a senior profit and loss manager. So you are like the executive assistant or someone who is like really the next person who this person goes to for finding out all these answers. And these are the most important business decisions, which is why data science has become so important, because we are all the time trying to optimize and we are trying to kind of get these answers, but we are not trying to guess. Earlier, managers used, gut feel, and, they just knew it from experience. But often what they found is that that reason was wrong. There was something else which was the underlying cause. So that's where even data science helps you in causality. What caused that, parameter, let's say material cost, to go high? And then, is there any correlation with any other factor? What is the data telling you? So that's where you're able to make data backed decisions, which is today's modern world, right? Today, no manager takes decisions on gut feel. They take it based on data. And by data, I mean what the data dashboard view is, which is where the manager has to interpret, and the insights that someone from data science gives, where that is basically the managerial insight, right, itself. So manager does not have to interpret anything as well. So that's the advantage of data science, that you're actually providing the entire recommendation to him based on your understanding of all these three pillars. And that's why data science is so important, right? Okay, so these are the kind of machine learning algorithms that existed in the traditional machine learning area. So you would have seen most of these. I don't want to spend much time on this, but I'm just saying that there will be a sort of background course which will teach you all this. So it's talking about essentially uh, uh, prediction and classification, which are the supervised learning kind of techniques. And so you can either predict something like future sales or future profits, or you can classify something as something which is important or not important, for instance, based on, let's say, their impact on the decision variable. And these require training data sets based on which, that's why it's called supervised, because you're already using training data to train the model. And then you have, let's say, a couple of unsupervised, which could be clustering and association. So, and then you'll have multiple models from that. So let's say the technique for clustering is k-means, or nearest neighbors kind of thing. Um, and you will have things like, let's say, market basket analysis, which is one of the techniques of association, where you try and understand, even if you have no previous information about the customer, which customers are alike. So you will have some map which throws up that, what kind of things do people buy together. So if, let's say, you're Big Basket or one of these grofers or one of these e-commerce companies, you want to know that, can you increase the basket size of your customer who's ordering from you, right? So something like market basket analysis can help you. Suppose you know nothing about that customer, he's logging on for the first time, you don't have any of his past order history. But suppose he orders something like, let's say, brown bread. Based on market basket analysis, you know that, generally these are high value customers who also order bottled water, right? So they want their Kinley and they want their brown bread. So typically, of course, a lot of people today are conscious, they want whole, you know, brown bread instead of white bread because of, various things like wheat base versus, dough base. But I'm just saying that, that is one of the things that, let's say, the market basket analysis throws up. On the other hand, there could be something where if you buy white bread, you might actually be also ordering juice, fruit juice along with that. So what you will tell the customer is, you will try and position alternate products where, which is nearest. And these are all coming from, unsupervised models, right? Like market basket analysis, which I said is association, unsupervised learning. So that's where I'm just saying that all these techniques will give you a very good feel of, how you can increase the basket size of customers, which is the ultimate demand of, let's say, your P&L manager, or if you are in a consulting company for your customer who may be, a big basket or grofers of the world, right? If you are designing a machine learning algorithm for them, they might want all these kind of insights. I'm just saying these are simple insights, but there could be a lot deeper insights around that, right? So this is pretty much what is going to be covered all through. So you will have various kind of bagging and boosting algorithms, support vector machines, all these you would have heard of. So they are all around increasing the size of basket, which is increasing the sales revenue, selling more profitable products, doing cross-sell, upsell, even doing fraud detection, churn detection. All these kind of things are part of, what is the outcome of the insights from these models. Okay. Then moving forward, again, these are all the models. I don't want to go through. There's a lot of, like I said, supervised, unsupervised, and then you have the k-means association. Supervised is prediction and classification, and then whole subset of all that, right? Parametric and non-parametric models. So if I can just spend 2 minutes on this slide, what I'm just trying to showcase is between traditional machine learning, which had statistics as its base, like I said, k-nearest neighbors, clustering, classification algorithms, all these were traditional machine learning. You also have deep machine learning. So what that does is it commoditizes the need to have very deep statistical knowledge, because see, what we want is the benefit of machine learning should be applicable to a large base of industry. So earlier, people would go and hire data scientists who came from a statistical base because they were the individual experts, right? Only they understood all these details around statistical model. They would say, okay, take this, take F value, compare it with this, take degrees of freedom, all mumbo jumbo, right? All statistical mumbo jumbo. Only they understood. Whatever they said, everyone did blindly, right? And how many such statistical people are there? So it's limited, and so the people they can influence is really limited. What deep machine learning did was they basically made the machine intelligent. So what that means is the machine is trying to mimic the human nervous system, or let's say what is called a neural network. So how we see an image and we think, okay, oh, this is a slide, this is a cat, this is something that I like, this is something I don't like, right? So these are things which are happening automatically. If you really look at it, you are, seeing various objects in front of you, and you are coming to a very quick conclusion. How is that happening? It's not that, a lot of statistical models are playing out, right? It's just how the neurons or your nerves are sensing it, right? So even as you see, it's not your eye that is seeing the slide, it is your brain, right? So your eye is really like a sensor or an IoT device, let's say, which is having the image at the back of your retina. And that image, when it gets transmitted to the brain, then the brain is interpreting this as a slide, and it has, 7 or 8 bullet points, right? So that is where I would say is exactly what a deep machine learning system is trying to do. Is it's trying to mimic the whole nervous system and the brain, where you are having a training set provided, which is under supervised learning, as we said, and it has these neurons which are connected to each other, and they have certain weights, right? So those weights is what is being trained. So the weights have a particular value, right? So if, for instance, you're seeing a white image, okay, white is not a good thing. Let's say red, okay, you see the red button on the top, right? So the neuron which has the red filter or color sensor is having the highest weight, and those which are having, let's say, blue and green are having marginal weight, right? Because as primary colors, we know red, blue and green are the primary colors, so the filters for those two are close to 0. Filter for red is close to 1, right? So that's how the weights are being determined for you to determine what you're seeing in terms of understanding the individual letters and the word and all that. And obviously your mind has been trained over so many years, and similarly colors and so on and so forth, and you can make out what is pink and what is red and what is orange, right? So those all are your filters being played. So as we say, each color has a value of between 1 to 255. So anything which falls in a different range is detected by the eye. So you can determine, let's say, 255 shades, maybe more, of colors. So that's what the machine learning algorithm filter is also trying to do, right? So broadly, what machine learning is doing is that the machine itself is training itself so that when you have a future input, it is able to predict it. So it's prediction oriented. Whereas statistical models is interpretation oriented, right? If p-value is less than 0.01, it means a factor is insignificant, so hypothesis is not true, all that stuff, right? Null hypothesis is false. So all those kind of things are interpretation based, right? Based on your understanding of statistics. Deep machine learning is giving you the output. It's actually giving you, okay, this is, desirable, not desirable, or the value of this is so and so, right? When you put in, let's say, sales data for, uh, whatever, 6 months, it gives you the balance 6 months data predicted. So that's what the trained model is supposed to do, right? And obviously, a regression model is the simplest model because it's just a linear estimator. Deep machine learning, the strength comes from its non-linearity, right? You have something called hidden layers. So a lot of non-linearity. So of any function, however curved it is in whatever n-dimensional space, can be modeled with n neurons based on adjustment of weights, right? So that's the whole exciting study called deep machine learning. So so these are the form of neural networks, and it's similar. I think Arpit said that it's been there for some time. I don't want to repeat myself, but in the early 90s, when I was a student of engineering, I used these for my bachelor's project, right? So I was doing a power line failure estimation. If someone sees the grid, it needs to detect whether, it's faulty or not. That means, is there an alternate path through which current can flow? I was an electrical engineer. So I had to understand that through something called a Hopfield net. So you'll see that at the bottom here, and something else called, backpropagation algorithm, which today again people say is new, but in the early 90s I was using it. But again, same problem. I had a 486 machine, no computing power. It took 2 days to converge, And obviously, that thing can be done in a fraction of a second, same problem today. And what takes 2 hours to converge, probably would take 2 years in those days. So that's the only difference that has happened. All these models pretty much existed, but there is something also called Kaggle. Have you heard of Kaggle? Can one or two of you type in whether you have heard of Kaggle? These are competitions with data sets, okay? Kaggle, okay? So yeah, Arpit has heard of this Kaggle. So today what happens is people are not interviewing you based on your knowledge of statistics or how, impressed they are with how you articulate things, because deep down you may not understand how to, use Kaggle data sets and do machine learning kind of thing. So yeah, Arpit is doing something on Kaggle itself. And in fact, this is something where now your GitHub repository, that is the place you store all your programs, and Kaggle data sets, where you use all kinds of, different kind of data sets to come up with solutions to, let's say, some problems, right? Which could be detecting fraud or, detecting outliers. And you could use some of these models from, there are some pre-trained models in Microsoft or AWS, Amazon, or other cloud sites. So all you have to do is basically know how to put it all together, and you can call yourself a data scientist, right? So is that enough? I mean, do you think that just being able to manipulate this and get a result is enough? So if that was the case, then data scientists wouldn't be paid as high as they are, because, like I said, two, three skills are even more important. One is to get deeper insights from insights. It was covered in the previous slide, where you have to keep manipulating the data, getting, more and more out of the data. The other is you have to have the business context. That means you must understand that industry very, very well, right? So if you have these two, then I would say that technology bits can be commoditized. It's not something that really requires, very deep understanding, because today a lot of these things have been, made very simple. Even Python, if you're an experienced programmer, you can use, a terminal, IPython and what have you. But if you don't, you can use Jupyter Notebook, where, it's like a UI interface, where to type, what button to press to execute that code, and so on and so forth. So all these things are become extremely easy to use. What you need is a slightly powerful computer, which is able to execute the model in your laptop itself. And then when you need more computing powers and GPUs, general processing unit, instead of your standard CPUs, then you can go onto cloud and, use those resources. And those are also free, by the way. There is something called Collab and other things. You can just get free capacity. Maybe it may not have the power of a Google Cloud, which is the paid version, but still, I mean, if you are experimenting, there are free resources available everywhere, right? So that's what makes this exciting, that it's actually, completely free, and it's something that anybody can do, uh, practice being a data scientist without being constrained for resources. And that, I mean, compute capacity or money or anything, right? So that's the exciting area. Yeah, Python or R, you need to do both, because R comes from a statistic base. So, it makes, um, you know commands very simple. Like if you have, something, in fact today my son was showing me how a 2-page chi-square analysis can be done in one line of R, right? But Python, it might require, slightly more details. But then from a statistics standpoint, I would say R is easier and better and more prominently used. But from overall machine learning, Python is the language, right? Python, if you know, I think you need to know very few other languages. I mean, Python, I would say, it gives you a good skill for doing all kinds of things like web scraping. You're pulling data off the web. You are, converting it to structured data streams or semi-structured through data frames. You are analyzing and creating models where there are enough Python libraries that exist. You're visualizing it in something called matplotlib, pyplot. So Python has very extensive libraries for all kinds of things, which R necessarily does not. So R can give you good stat tools, and it can give you visualization, some capability. But I would say if you have to pick a stat base and programming language, you should have both R and Python. And then I don't think you need anything else. And worst case, suppose you still think that, okay, you need to pick up some language, then, it's a, I would say, throw up between a object-oriented language like Java, C++, or functional programming language, which is the new rage, like Go, right? Which is like, let's say, blockchain. A lot of these languages use functional programming languages where you can use subroutines with functions as parameters, right? So that makes things even simpler or fewer lines of code, but it requires, deep understanding. So you can either choose Java, which is the most used language, and use object-oriented language. I don't think it's going away very fast because most of the developer base is Java and .NET. Um, but if you look at Python, I would say Python gives you the most broad-based programming skill set. So it's a must. You must know Python. And if you are focused more on data science and data analytics and statistics, you should know R as well. And if you want to also get into programming and do that and be, a general purpose person who is a one-man army, then pick either object-oriented programming language like Java, C++, or um, functional programming language, which is the new rage called Go. I think there are a couple more, but Go is the more prominent language, and it's the programming language of blockchain. So it'll give you machine learning, blockchain, IoT all in one, right? So I would say just try and use that, right? So this again, there are multiple type of models like CNN, RNN, LSTM, GAN, all that stuff, right? Which are variants, and now reinforcement learning, which are all variants of deep machine learning. So for CNN uses models which train on recognizing, let's say, images, right? So it can determine that this is an image of a cat or a dog or whatever. It can determine whether handwritten digits which you see on the left are actually what they are. So all these, if they go in, should be interpreted as 0. Any of these should be interpreted as 6, and so on and so forth. So this is called what is one hot encoding, and this kind of gives the final result here. But then it goes through multiple hidden layers, and so determining these kind of convolution layers. So these are what is CNN, like convolutional neural networks. So these are basically things which have filters which are reading the image. So each of these are coming as 28 by 28 pixel images, and then they are going through various edge detectors and so on to picture detectors to overall image detector, and which is then classifying this as 0 or 9 or whatever, right? So this is the architecture, and this is what Kaggle competitions are, right? So Microsoft, Google, everyone take part, teams from them, and they try and make things more efficient in terms of accuracy, right? So you have to have a 99% or 99.5% accurate estimator, which means that post training, if I give any image, it should be able to detect that correctly 99.5% of the time. So that is where the Kaggle competitions are, which whoever has the highest get into the leaderboard and all that. So these are more for ensuring you're top of the hierarchy in terms of being a data scientist, and that's how people keep themselves top of their profession, right? It's like gamification of your competency, which is what Kaggle competition is. One last thing I just want to leave you with, which is the theory part of what I had to talk about, was that I don't know how much time we have. Okay, we've kind of pretty much done 40 minutes. So business intelligence and data science are different. So business intelligence is really about the standard reporting we have in organizations, which is from ERP systems How do you talk about what your last quarter, last 9 months sales was, profit, etc., etc. If you want to pull out additional data, that's called ad hoc reporting. Then you go and do SQL queries or no SQL queries, and you basically get information out. Typically, the IT person is the most important guy here because he knows how to query the database. Most of these tools are, you have to learn how to use SAS and, SQL querying kind of thing. So this was the old model where the business person and IT person were two in a box. A business person would give the domain, IT person would get the data back. Then boss would say, no, this is not good enough. Then business guy would again take the requirements, go back to the IT person. That person would come back and say, no, this data we don't have. So make do with whatever you have, etc., etc. Right? So this is all restricted to within the organization structured data. Very limited scope, right? As you see the size of this area under this curve. And then data science is pushing the boundaries out, right? So one is you're trying to use deep machine learning and so on. Arpit, I'll come to your question in a minute. And then you're trying to move out in terms of the time of data you can collect and the type of data you can collect, right? So like I said, you're collecting external data from data sets. You are looking at host of structured and unstructured data. You're converting the unstructured data into semi-structured or quasi-structured data so that it can be analyzed as one more X variable or feature, which is predicting the Y variable, and so on and so forth. So essentially, data science is all around optimization. It's around, what is the best answer? Or if this scenario has not been seen before, what is the best way to act, right? That would not be possible here because you don't know. You don't know whether you have been acting in a ad hoc or a semi-optimum manner because you're doing gut feel based decisions. So how do you then, with this data, be able to do what is optimization? So that is what these data science tools enable you when that machine learning model has trained itself to be able to give you the highest accuracy. So for instance, human accuracy, I think is, I don't remember what it is, but I think it's 92, 93% for images and maybe 80% for speech. So if your machine learning model is 99.5% versus let's say 92%, means the machine learning model is performing better than you. That means even the best person with the best experience and best gut feel is at 92% and this model is at 99.5. Similarly, if you are having a problem with understanding someone's accent, like you're talking to an American or Australian, and you interpret 80% of what that person is saying, rest all is not this. Suppose you have a translator or speech translator, which is 85% accurate, then you know that you have got bigger accuracy. But again, the training data set of understanding that accent or understanding the nuance of that industry or what is the commonly phrased terms, all has to be taught first, right? So that is where the RNN model is trained for speech and text and natural language, processing kind of applications. So SQL most suited. See, today most of the people are going into NoSQL, which is all the MongoDBs, Cassandra, CouchDB, and all that, right? So those are because they are columnar. Because each row, that means each person may have different types of data, right? So if I may give my email address, phone number, mobile number, home address, etc. Someone else, let's say another professor of the institute, may just give his email address, right? All of us give different pieces of data. Now, if you have to populate this in a typical SQL database, then it's not very efficient to pull data because all those half of the fields are empty, right? So SQL databases are good where you have a tabular form where the same data is populated, few number of columns, which has data sets, and it's easy to manipulate because those are what is pivot tables, right? When you put it into a pivot table in Excel, these are coming from very structured data. Excel itself is structured, right? But when you're talking of new data sets where you're pulling off data from websites, people have given different kind of information. Some people have not even given their name properly because they don't want to be spammed or people calling them any time of day, etc. Then those go into something called NoSQL databases, which are columnar databases, which could be hundreds of columns wide because someone could have given his grandfather's name or mother's maiden name, something, right? which could be different from what all the other people are giving. So all these have to be fitted into a separate column. And anyway, so NoSQL is good for large data sets and for applications which are not very time consistent. That means at one point of time to have a very consistent data is not so important, right? So those are what NoSQL databases are. But if you have need for consistency, a lot of uh, need for accuracy and all that stuff, then you will go to a traditional SQL database, that's structured query language, SQL, which are what the RDBMSs are, right? So you have Oracle, IBMs of the world, DB2 and Oracle database. Those are all SQL databases, which are the conventional. So your learning has to be SQL querying, which is on traditional databases, but you will also have to know, how to do API integration with NoSQL, pull data, all that stuff. So it's a combined course, and that will be taught as part of the whole, program on databases and SQL querying and so on. Okay. And so from here, all the optimization and structured, unstructured, what if kind of analysis is what data science gives you, right? So I think we have spent quite a bit of time on the theory, but hopefully that gives you an idea of what is data science and what will be taught in a course of this kind. What I want to differentiate is what is the difference between a business MBA in data science and a master's in data science, right? So a technical data science program and a management data science program. What is the difference, right? So the difference is, again, one of the three pillars is business context, understanding of business. It is not that someone who comes from a technology side does not understand business or he cannot pick up things fast, right? The only thing is that someone who also understands finance, understands marketing, understands HR, understands, organizational behavior, is in a much better position than a standard engineer who is trying to get deeper skills in data science to be able to understand what is the problem definition from an organization context, because you have done balance sheets, you have understood profitability, you're not kind of trying to kind of figure out on the go. You understand in your internship programs how to kind of really solve business problems, all these kind of things, right? So these are what a traditional engineer doesn't get exposure to. Maybe some courses have like a dual degree in some management course, etc., etc. You have some BBA programs which are business focused. So it depends on what your exposure is. But what I'm just saying is that is one difference. The second is it is being taught by people who are experts in each of these areas, right? So who would I want to teach me if I wanted to understand management, management sciences or management program? I would want to be taught by people who teach in business schools, right? Not, people who are sort of probably industry people, but, are coming at it from more the algorithm standpoint. And from a data science standpoint, I don't want, people who are generalists from management side to teach data science, because they don't have that deep exposure into practical problems where you're building up skills so that you go on to the job on day one effective, right? So any problem that is given to you, you understand the business context, you are able to formulate the problem, you are able to kind of go with your stat and math knowledge, define that the actual model that should be used. Then you go and look at the data and you see whether those models can be used or not. You understand what additional data sets you need, whether they are free or paid. You kind of decide whether they. So you're basically pulling off all three streams where you have learned from the experts in management and from data science, right? So that's what makes a problem. That's what makes a program effective. So, of course, a lot of this can be taught, self-taught. But I'm just saying that when you look at these kind of problems, which are real problems, if you look at employers like Flipkart, Amazon, big banks, or telcos. Now telcos are not doing so well because of various issues around 4G licenses and all kinds of problems that the telecom sector today finds itself. But 5-10 years down, telecom was the highest desired employers, like banking and financial services. And retail today, if you really look at supply chain retail, I mean, they are now coming up to be solving real problems for big retailers in US. So you look at Target, Walmart, the kind of problems they're solving are best in class, right? So whatever it is, finding out customer lifetime value, forecasting anything 2 years into the future based on some training data sets, understanding customer churn, understanding whether in 10 minutes you can give a loan to someone who doesn't have a credit history, matching fingerprints like in your mobile phone without image processing, something called capacitive checks, recommender systems, like I said, you're filling up your basket or predicting what kind of data you need, optimizing your route to deliver products, whether you're a big basket or Swiggy or what have you, how to keep the truck packed to maximum capacity, minimizing the number of trucks. So these are all real problems being sorted out by any kind of company today, if you really look at it, who's a desirable employer, right? Which is what makes data science so important for these kind of employers and makes you relevant in the scheme of things if you really know and you're top of the line, right? Which is where a very deep program, full time, gives you that kind of thing which, let's say, an online program cannot teach you. Online program, even if it is let's say 6-9 months, is not going to be able to teach you everything from the management side as well as the data science side. If you look at the origin of colleges, and that's what I think even IFM found, that if we as a business school start teaching data science, I mean, we don't really have the professors who really come with that kind of, domain and practical exposure that, like, deep data science schools do. And data science schools have exactly the same challenge with management courses. So that is what I think I'm coming to, really talking about, like, if you really look at all the skill sets that are required from, this is more related to data science, where you have to ingest the data, do the model building, all that stuff. Or you look at specific skill sets that are required in data science. The only reason why you are effective is that you are marrying the knowledge of the organization and the business and the future and the data science parts. So if you have 0 to 4 years experience, typically you go into a role as a data engineer or a data analyst, depending on how deep you are in that field. So you basically do all that, getting data from Kaggle data sets or your internal data, and you have to have exposure in R and Python, as I just mentioned, stat modeling. You have to know statistics, what is the correct model to use. All you need to know is the name of the model, okay? All the other stuff is already coded in a library. You don't have to really build the model from scratch. And then how to visualize it from a management standpoint, because you have that view. So how will your managers interpret that data, right? So that is also very different, because if you just throw up something which is not easily interpretable, then your managers are struggling. And obviously you have to know querying languages like SQL query and some programming tools like we talked about. Once you kind of move to the next level where you're managing a team of data engineers, you become a project manager, which is typically 4 to 8 years. So you could be designated anything. You can have a vice president title, you can have, director title. It really means nothing from a functional standpoint. What we are saying is you're now a manager of a team of data engineers, and the project manager is someone who's now managing and ensuring the team is able to give realistic timelines, because you have that knowledge. You're not coming from outside or not a data science person where people can take you for a ride, right? Because only to be effective, you have to be able to know that task yourself, right? So that is why it is important that you go up this path rather than come laterally into something. And then you obviously have a view of the right algorithms to use. You can guide the teams. You understand both traditional machine learning and deep machine learning, and whatever new models that come up in AI, things are changing so fast. You have to be a master and have that ability to keep learning, because what you learned here will probably be completely different when you're here. And then you move on to a project executive, or someone who's actually dealing with a client and solving his problem. This is where skills of both the business domain and the design thinking skills, right? You're trying to understand which is the problem you can solve to give the fastest result, right? What is called low hanging fruit. You are excellent at going through those kind of business process mapping with the client, understanding which problems to solve now, which problems to solve in 1 year, which problems to solve in 3 years. So you are really the face to the customer who's responsible for the overall delivery. Okay, and you have multiple projects under you, and each of these project managers running each of those projects report in here. And then you move into a, let's say, VP of data science, or chief data officer, or chief digital officer, or chief marketing officer, for instance. See, marketing today uses all digital tools, right? So how your digital marketing effectiveness, everything is playing out, is all based on the same data you're collecting from websites and third-party sites. So your path to CMO or CDO is all really dependent on this. And maybe you need to pick up one more skill called cybersecurity, and you can also play the role of a CTO. So it really depends on what you want. I mean, typically the CMO is a profit center. He is typically a P&L lead. A CTO is more like a person who is a functional lead, right? So he's like a CFO, and CTO are people who are common to the whole organization. They are looking at it more from an organization security standpoint. So a CMO is someone who's leading a campaign, trying to get new products into the market faster, and so on and so forth. So this is really the career roadmap that I wanted to talk about, and how you can actually get to a CxO level position by just being consistent, by becoming a practitioner and keep learning data science concepts as you go along, and also the new concepts as they come along. So you become a perpetual learner, and you are someone who understands business context from different industries. So what your exposure here could be multiple industries. Here you go and specialize in one particular industry, right? So and then you become, let's say, the retail national partner for KPMG, or I don't know, one of the big consulting firms who are BCG and so on, for retail or banking or telecom. But then you're only dealing with that industry, but you're the person in front of the customer, trying to showcase how data science projects can help the customer reach his goals. And if you are within an organization like Target, Walmart, Flipkart, etc., you move into a chief data officer, a chief digital officer role, and then you sort of get your $1 million salaries, right? Everyone knows Puneet Ranjan came from Bay Area at $1 million salary for Flipkart. So what I'm just saying is that these are all which require years of experience. Puneet Ranjan came with 15 years experience from Bay Area, the Silicon Valley. Today in India, we are looking at people who are typically 10, 12 years minimum, who would go into these kind of roles. Earlier, someone with 30 years experience would fill these kind of roles, right? You're getting that role in, let's say, 10, 15 years. So, but then careers are also short. So what the insulation against that is that you become deeper and deeper into a particular industry, so that you are the port of call whenever any data science issues come about, so on and so forth. And you're someone who is kind of always picking up new things, so that you never get outdated. I'm 50 years old almost, maybe in a few months, and I'm learning every day. Okay, so there is no, I couldn't say that, okay, I have 23 years or 25 years of industry experience, I've learned enough, I don't need to know anything more, because then I will get obsolete. Okay, so what I'm just saying is there is no real, end time, and careers are getting longer, by the way, right? Because, how much we need to retire is increasing. Our careers are getting shorter, because if you become a person who is not performing, or not dynamic enough, you lose your job. And so then it becomes, okay, how do you survive for 20, 30 years in your career. And today careers are moving beyond 60 years to 70 years. So then how do you stay relevant? So you typically become a consultant, do your startup, whatever. But you have to be productive till you're almost 65, 70 years old. So how do you do that when technologies are changing so fast? So that's only this ability to keep learning, keep attending webinars, keep doing new things, keep learning about different models, different problems that are coming up in industry, and doing it with enthusiasm, right? More importantly, not doing it because you're forced to do it or so on. So that's really, I think, the key skills that are needed to be a CxO. So I will just probably end there and see if there's any questions you have. So I've taken exactly 1 hour since we started. So I'm sorry, I should have probably ended 10 minutes earlier. Just that sometimes this area is so exciting that you get, sort of carried away. See, there are slides which talk about IFIM itself, and the fact that we are grooming T-shaped professionals and all that. So maybe I have mentioned all these, that you have your business exposure, you have all the practice courses from a business standpoint. So you have things like your whole internship, you have mentoring programs with industry, you have corporate mentors, you have research projects which are deep in, but it could have both contexts. And then you have the data science courses, electives as well as super specializations, which make you ready, job ready from day one. So whatever questions you have, you can just post it. Okay, how to start learning data science? Just type data science in Google and say course in data science, and you'll get 20 things thrown up on Coursera, edX, etc. You can just go and pick up. There are plenty of material, online courses, etc. All I'm trying to tell you is that sometimes what happens is some of these courses may have things which either are too high level, or they go into one area very deep, which then you start losing focus because you say, okay, this is boring, right? Once you get into that context that data science is boring, then coming back, unlearning all that, and then getting back into a actual data science program which gives you that exposure to all that we talked about is a story in itself, right? It's similar to someone who has a something where he feels maths is tough, right? So there are plenty of people like that, right? 80% of the people find maths tough. Now, whatever they see in maths, they will say, I don't get it, without even seeing the problem, because in the back of their mind, it's something is programmed saying maths is tough. So I would say some of these online courses, be very careful of what program you're looking at and whether it justifies what you're trying to get. But if you are trying to be a data science professional, get into the right course. So whatever be that course, right? I'm not trying to talk about this course or that. If you want to get into the management cadre of data science, that means you are a data science specialist, but you are on the path to a management position, which could be a general manager, vice president, whatever, right, in data science. Then I think you need a MBA in data science. And there are various people who are offering MBA in data science as well. It's called, PGP, PGVDM, or PGP in Advanced Business Analytics, IIM Ahmedabad, right? Now, who are the people who are teaching you that course? They have people who are very good. I myself am a student of IIM Ahmedabad, so I can talk about it very convincingly. Have very good people in marketing and finance. But, do they have people who are very good in IT, MIS, data science? Maybe not. Okay, we used to actually find that you had very good people in marketing and finance and organizational behavior and HR and public policy and operations management, but we didn't have people who are good in IT and MIS. I mean, actually, anyway, I'll leave that. So that is the challenge, that a program like this will never have the kind of depth in data science, is my view. I could be wrong. Similarly, if you look at some of the people, some of the other courses, which are done by technical institutes. They're doing MBA in data science. They might have very deep data science programs, but do they have the same in management programs, management courses? Maybe not, because see, to build a business school, to build a faculty that kind of thing, will take you 10 years. You can't do it overnight and attract the right people, because all the good faculty will wait till you establish yourself. And if you really look at IFM Business School also, it has taken time to attract very good faculty after it got AACSB accredited as the sixth institution to get AACSB in India as a business school. And similarly, our partners is a school called INSOFI. INSOFI has been the fastest rising data science training school, where what they basically taught was a 6-month program called PGP. It's a certification program, part-time, 6-month, intensive, but part-time and online. What that is doing is it's giving you exposure in data science, but it's not making you an MBA in data science. That's where we felt that if we can combine the strengths of both schools and do this, we would be far more effective. There's only one program in India, by the way, which is comparable, which is the course run by IIM Calcutta, ISI, and IIT Kharagpur. So you have ISI, which is Indian Statistical Institute, the oldest, like St. Stephen's, the oldest, statistical, college in the country. All the, Niti Aayog, Planning Commission people come from ISI, right? So it's very reputed. IIM Calcutta brings the business courses, and IIT Kharagpur gives the technology. So the three pillars, right? One is giving you statistical models, ISI. One is giving you technology depth, IIT Kharagpur Computer Science Department, and IIM Calcutta giving you the business courses. So if you join a program like that, you'll have to spend 6 months in Kharagpur, 6 months in ISI and Calcutta, and 6 months or 1 year in IIM campus, right? So, and then you can get the similar kind of exposure that a course like this would give you. And here you're either in Bangalore or Mumbai, depending on where you choose to locate yourself out of. You could do the same thing over 2 years and get that kind of exposure. So that's what is different. Okay, you have experienced faculty who are teaching you what they are good at. So if I start teaching data science, I can pass off a lecture like this, but I will not have the depth of what the INSOFI professors have. And I'll just talk about some of these people. They are people with PhDs in the US, from Carnegie Mellon and Johns Hopkins, all the best universities. They are people who are teaching you structured data. Big data is itself a specialization. Prof is teaching blockchain, deep learning, text, and NLP, right? So the specialists in each of these areas. Dr. Lotlikar is 48th ranked in IIT JEE, right? So I hope you know what that means, right? He's 48th out of 150 people who gave that exam in 1989. He's a batchmate of mine, classmate actually, from IIT Bombay. Okay. This gentleman, Anand Jayaraman, again IIT Bombay, spent 18 years in Wall Street, right? To come and teach financial markets in SOFI. I mean, where would you get these kind of people to teach you data science anywhere in India? And Dr. Venkatesh Sunkad is actually the dean of this program. So in fact, you'll probably be seeing him very often if you choose to join this program. He is from, he's done a PhD from the US. He's someone who was a vice president at Vodafone. He spent, I think, 25 years in the industry, and now is, the dean of this program. And he's an IoT specialist because he comes from Vodafone IoT practice, and along with Parag Mantri. So they're all people who are actual practitioners who can really teach this course with depth. And that's why this program, I feel, would be, first of its kind in India, because I don't think these kind of people would exist even in IIT Kharagpur or, IIM Calcutta to teach you this kind of things. Yes, IIM Calcutta would have some people who are coming back from the US and now teaching in IIM Calcutta, best IIMs, right? So that kind of exposure is more from a management discipline standpoint. But when you talk of deep technology and practice of those problems to industry today, because these people have been working in India, it's not that they are working overseas, they can actually customize that depth to you. So Coursera, yes, is a good option. EDX, you can pull off any course you want. But what I said, last 5 minutes stands, right? I mean, just make sure you don't take one course that puts you off, saying that, oh, this is too hard, or oh, seems like a general program, right? And I can tell you that because, like for instance, I teach a fintech course so I was trying to pull off from some of the fintech courses which are there from various universities. Surprisingly, the best management school in the world, okay, which is Wharton, University of Pennsylvania. The fintech course there is actually a shadow of what you would expect, right? So what I'm telling you is just the stamp of the university may not be enough. Whereas another university, which is Hong Kong University, runs a fantastic program on fintech because they actually have people who have been working in Hong Kong Stock Exchange, etc., pulling off their knowledge and teaching you how basically startups are actually innovating in Asia, and these are all relevant from the Asia perspective because maybe the kind of customers are similar in terms of their asks, right? So TechFin versus FinTech, right? So China comes at it from the tech side and then builds that functionality into finance and so on. So you have to be very clear who are the people guiding you so that you get the right guidance into this program. And it will be I would say, a very structured approach. So it cannot be that, I'm trying to teach you in 2 hours and give you what is deep learning. Because if you learn that way, what you remember is only the terms, right? So you can go and impress someone with what an SVM is or, PCA is and whatever. But, beyond that, your knowledge is not deep enough. That is where you need people like in Sophie, and business side, you need people from IFM who are kind of covering all these programs in depth, right? And that's where all the certifications are there. It's a full-time program, 2 years. You have to give up your job if you're working. It is not going to be something which is done once every week. It's you have 35 data science practitioners who are guiding your capstone project, right? So it's not just something done in class and okay, you go do your homework. If the program runs, that's fine. You get your grade. Is that program deep enough for industry? If that program is not working, who helps you get that program working? Are these 35 data science engineers who have between 5 to 15 years experience as data scientists, who are actually sitting with you on your computer and ensuring it works. Okay, currently we work in online collaboration mode, but eventually when we come offline, that's how it will happen, right? In a workshop. So this is the kind of real handholding that will ensure you become an expert, rather than someone who has some certificate to flaunt. And by the way, you will have two certificates. One is a PGDM in data science, which is the MBA in data science, and you have a PGP certificate, which in Sophie provides for people who do the 6-month program. So you have both bundled in that cost, which is 10 lakhs. And where could you get a course like this for 10 lakhs even in India? Okay, I mean, if you go and find out what the competing courses cost, I mean, everything is 16 lakh plus for part-time, semi-part-time, 1 month immersion kind of programs. Here, this is full-time, 2 years. Okay, so just be mindful of what you're comparing versus what. And some of the online courses themselves cost 2 lakh, 3 lakhs, right? So what are you getting at the end? You're getting a certificate, maybe some foreign stamps. Does that help you get a job? You need to talk to people in the industry and find out. Okay, don't take my word for it. Okay, so yeah, what is the standard prerequisite? Yeah, I mean, the right mindset. If you are trying to solve an industry problem, if you say, I'm not challenged by math and I'm willing to learn from the right people, that's it. I'll give you an example. My son actually gave up 11th maths in 11th and 12th. And today he's doing a BCom in analytics in St. Joseph's in Bangalore. And today he's learning R, SQL, everything without doing maths in 11th, 12th and as a BCom student. So you can imagine it's your interest. What do you want to do, right? It's not only for computer science engineers who have done, deep technical stuff or people who have done maths in their bachelor's program, all that stuff, or statistics, right? It's not for them alone. Of course, if they come from that background, definitely they will be at an advantage for some time. But we are hoping that the professors take you up the curve fast enough so that you're all at par at some level, depending on your effort as well, right? I mean, if you expect that everything will be, um, spoon fed without effort from your side, not going to happen. Equal effort, you'll be at par. Okay. So someone is saying, Shonali is saying I'm not audible. I'm at actually the highest level of. Am I audible now, Shonali? Okay. So look, I think for whoever is there, look, there's no shortcuts. It will be intense, but that will be the value of the program, right? I mean, when we went into our program in IIT and after that in IIM, what was the differentiator in those programs was the extent of competition. When you are with people who are competing hard, that makes you work hard. But if you are, let's say, in a program where everything is easy, you don't have to do anything, you just attend classes without taking notes, you can go back home and watch your Netflix, come back next day, and people will repeat themselves, and you basically just come and attend class. Your level of diligence will determine that you will be 50% of the level of that person who tries hard. So this will be an intense course. It will hopefully be recognized as such, and that will give you the best jobs, by the way, because finally, net, we are all here for jobs, right? So I actually just wanted to end with that slide where look at the kind of companies who are hiring today from Insofi for the 6-month program. So for the MBA program, clearly, this list is going to balloon up. We have 500 recruitment partners between us who are, the BCGs and Target, Amazons of the world, Flipkarts, who are the highest paymasters. I mean, they are product companies, right? So if you go and talk to anybody in the industry, there's a huge gap between services and product, right? I myself used to work for IBM for 10 years of my life, and I know this industry inside out, right? As both a person who worked first for corporate development, business development, and then for sales. There is huge difference in salaries. Okay, and that is what this program is actually enabling. That even for a start person who comes without any experience, if he does this, we believe the salary range will be 10 to 15 lakhs starting. If someone comes with 3 years experience, knows some industry, and does this course intensely such that he gets a good, let's say grade in the program, he could be picked up for 20 plus lakhs. So which job, MBA job alone, is giving you that kind of salary for, let's say, someone with experience? Hardly anything. I mean, you look at average salary from even the IIMs, it's I would say 15 to 18 lakhs. If you look at other colleges, I would say it's sub 10 lakhs. So this is actually helping you get a higher pay than a general MBA. And if you have the potential to go into an IIM and get that high paid MBA job, that's fine. But what I'm just telling you is I was that general MBA from IIM. I graduated in 1996 from Ahmedabad. What I found in my career is that the general MBA is not going to help you. And that is where you have to keep learning as you progress in your career. If I said I was a finance guy. If I'm a finance person, I can last in investment banking, mergers and acquisitions, private equity for all my life. Maybe few people, I would say 10% of the batch are like that. But what's happening to the balance 90%? They're either out of jobs, or they are individual consultants, or they sort of, are really, probably not doing something that they did or specialized in, right? So what I did was I moved from investment banking finance to a role in automotive, where first I was a, head of corporate finance of the auto company, but then I started a business which was in supply chain area, which didn't exist. So I created a new business from scratch. that gave me a lot of exposure into, startup, being an entrepreneur. So I was inside the organization, a corporate called Sona Group, Sona Koyo Steering, created this business which supplied auto components into Europe. So I understood mechanical engineering and how parts get actually sourced by these tier one suppliers in automotive industry, new industry to me. Of course, I was an automotive investment banker before that, so I understood auto well. But I didn't know anything about mechanical engineering and CAD CAM drawings and shop floor and all that. I learned that on that job and how to source those kind of parts. And then I joined IBM. I knew nothing about IT industry. I first became the head of M&A for IBM India. And then I moved to a sales job where I actually did large, deal sales roles in industrial, banking, insurance, basically, and public sector, where I led deals where I was supposed to be the head of people who were solutioning. And I knew nothing about IT solutioning before I joined IBM. So how can I, as a MBA, be able to run a matrix organization with people who are IT solutioning, basically on the application development maintenance side, the lawyers for the contracting side, and the pricers for the pricing side. So all these people reported into me, and it was a matrix structure where I did deals with this kind of thing. But what I'm just telling you is these are all skills that you have to pick up on the job. If I said that, okay, I know everything that is needed from the management side, I would never be effective in my job in IT services because I knew nothing about IT. And as a result of IT, I started leading digital projects, which today this data science, I'm able to talk something on data science because of that kind of exposure. But this was all things that you picked up on the job, but not done through a structured program. So if you do a structured program, that's when you are able to convince an employer that you have that skill set. And today the markets are all hire and fire, right? So they are people, you're not going to have benefactors or people who will allow you to retain your job. What is the number of people who have lost their job in this pandemic? I mean, if you look at US, it's 25%. Okay, or I don't remember. I think it's 25 million, people in white collar jobs. And in India also, the number could be similar. So what I'm just telling you is that, there is no guarantee of any job. You have to be top of the game. You have to be the number one or top 5 people in whatever you are doing. And anything that helps you get there, you should embrace. And one tendency we Indians have is that try and get free knowledge, like attend all webinars and everything kind of thing. But everyone will be talking plus minus 10% of what I'm saying, and someone will talk about something more interactive. You write down something on the whiteboard and all that stuff, but essentially the messages are all the same. If you are planning to be an expert in any particular area, you will have to go deep, and that will only come through a formal program. That formal program may be free. I'm not saying something is paid or free, like there is this Bangalore School of AI. If you actually go to them, and now of course they started charging 4,000-5,000 rupees. So you can actually learn something which is cheap. You don't have to spend a lot of money. But all I'm saying is any knowledge comes at a cost. That cost is also your time, right? We don't value our time. We say that, okay, it took us 15 hours to learn a concept, but someone could have taught us in 5 hours the same concept equally well. So I actually spent 10 hours additional, time, which is also cost, right? So you have to look at it both ways. What is a structured way to learn? What brings you deep data science skills? And what is also, something which is a reasonable fee for the value that you're getting. If you're getting a 10, 15 lakh job and you spend, 10 lakhs, I think it's worth it. But if you are getting that same 10 to 15 lakh job and you spend 30 lakhs for a foreign MBA, and it takes you 10 years to repay that 30 lakh loan, definitely not worth it. If you, let's say, do an online course of 3 lakhs, I don't think you're getting that 15 lakh job. You might get a 7, 8 lakh job, right? So then, you're getting a differential pay of 8 lakhs and, you multiply that over the number of years, you realize the value, right? So I think it's really you as the owner of your own career. You know best. Maybe your parents can guide you to a certain extent. Maybe people like me can guide you to a certain extent. But finally, the call is yours, where you see value, and therefore join the right program, whatever is right for you. And every one of you in this call could have completely different objectives of what you want to get out of, a knowledge of data science, right? So for someone who's just saying, look, I'm very good in my current role or job, and I just want to keep learning about data science, just attending free webinars is fine. But someone who wants a job in data science, high paid job, etc., you have to join a structured program. If you have to get a high paying job, you have to have exposure of both management and data science. So choose a course that gives you that good exposure, right? So is it better to take up this course with 1 to 2 years of industry experience? Absolutely. Absolutely. I had 1 year of industry experience before I went to my MBA program. IIMs have this concept that every alternate year they take people who are fresh from college. So in my batch, there were only some 10 people out of 180 who had industry experience. And you could see the difference between what these people brought to a case study discussion versus, and you'll be taught through case studies, by the way, right? So actual problem that you're solving for a particular client, it's all, getting into actual problem solving with context, right? Which is what a case study gives you. So the kind of insight you could give was very different from someone who just came fresh. I mean, they could be the brightest, right? So the people who did the best academically were the fresh people because they were the closest to academics. Maybe the people with experience could not match them in terms of how fast they picked up concepts or, did, the answer writing in terms of, theories of economics and all that. But if you looked at case study or discussions, the people who were talking most in the class were the people with experience. So definitely people with 1 to 2 years experience would have a lot of color to throw to the class and therefore could pick up a lot more. And that's why there are two courses abroad. One is called MIM, Master of International Management, and MBA. MBA, if you look at any of the big business schools, they don't take anyone less than 3 years of work experience. The best schools like Harvard, etc., will require you to have minimum 3 years of work experience. Some schools like MIT, Sloan, etc., could take you with 1 or 2 years experience. But all the best schools for MBA will require minimum 3 years work experience. Executive programs will be 10 years plus, right? So that is definitely, they want a lot of interesting discussions there in those programs. For MIM are the programs where you actually go fresh because really your knowledge is very theoretical. But does that mean that you pick up nothing if you have 0 years of experience? Not at all. I mean, that's where the industry practitioners teaching you make a difference. Suppose you had theoretical people teaching you, people who are, what we call researchers or scholarly academics. These are people who have remained in academics all their life. So they have gone from bachelor's to master's to PhD and come to teaching, right? So they have never been in industry. Then in India, the challenge is that academics is one side, industry is the other side. And suppose this person has not had exposure to industry for whatever reason. That person teaching you will be, completely ineffective for someone who is fresh from college. That is where this industry practitioners, if you look at each of the professors, and the profiles are there, Shonali can share that with you. They all have 15 to 20 years plus in industry, before they have come back and they have a PhD, etc., etc. Now they want to teach and give back. And you have people who are data scientists. That means they work in this line day in and day out and who are guiding you in the capstone project. And you have a good mix of researchers and academics and industry practitioners in the business courses. So you have, I would say, 60-40 mix. So people who are very deep in management science and people who are coming from industry and giving you, like myself, right? I teach a course on blockchain. I teach a course on financial technologies in digital platforms, which is called Introduction to Digital Business, digital technologies, which are the industry pillars for Industry 4.0, and data science, Introduction to Data Science, which is basic statistics, right? So I teach these 5 courses, been lucky to be able to teach this with an industry perspective. So we are all people who are teaching. We are not administrators or, people who just come and, do webinars. And on the other hand, we come from the industry, so we understand what are the critical problems. So being an IBM, I know how the data science team limitations are in terms of what they can or cannot do as a large organization, and what are the skills we are teaching you to be effective in those large companies. And similarly, service versus product companies, where people from Insofi have that knowledge so that you can get into a job which is, product data science, which is very different from trying to get into data science as a digital person from a conventional ADM or, maintenance or delivery kind of role, right? So you'll have to go through that full curve in a full-time course. And IT people, I think, are ideally well suited for this course because, I mean, your career is stuck in after a couple of years. You're in this sea of people, of 100,000 people or whatever, 20,000 people. How do you get to the next rungs fast? And that's where you need to come into a management cadre or, change your industry, change your mode from, like I said, to a product data science, which is also much more interesting, right? You're solving real industry problems versus doing some delivery of some boring delivery project. I can talk frankly because, I spent 5 years in that sales role. And these were, basically maintenance of SAP and, all these legacy platforms. And when you do solutioning of that, you realize that, I mean, it's estimation of effort, which is how many people or what skill set need to man a project. There is no IT skills required there, right? It's more project management skills or project estimation skills, which are really boring stuff, right? So anyway, so I will leave you there, and I think I've gone well over, but I just thought I would try and give you my perspective of things because I have that industry context. So choose wisely. Whatever questions you have, you can probably send it to one of our counselors, and I will just type in my email address as well. You can send it directly to me, and I'll try and answer you in in a couple of hours if time permits. Of course, these are busy times. I'm correcting a lot of NSEM papers and doing all kinds of academic stuff, which we have a date of announcement of the results. But if I have time, I will try and respond as fast as I can. So thank you very much, and hope to see you in the program. Yeah. So bye for now.